Hello, my name is Bhakti and my group members are Archana, Shravani and Shreya, and we are from Cummins College of Engineering, Pune. Our topic for the project is velocity estimation for autonomous UAV landing, and our guide for the same is Dr. Dipti Patil ma'am. To give an abstract about our project, we have an aerial vehicle with an onboard camera which captures the video, and from the image frames of the video, our goal is to calculate velocity which will be used in facilitating soft landing of the aerial vehicle. To calculate velocity, we have trained a convolutional neural network which maps raw pixel from single front facing camera directly to the velocity. For the dataset for this training, we have used Airsim Simulator which is built on Unreal Engine 4. To talk about the motivation, as we know, one of the prime reasons for the failure of Chandrayaan 2 was its abrupt landing. It was found that the velocity at the time of landing was way higher than what was expected. This makes it clear that velocity estimation is very critical for ensuring soft landing of any aerial vehicle. Moving on to the applications, aerial vehicles have a number of applications. They are extensively used for military purposes. In agriculture, they were highly used during COVID times for surveillance to ensure that the COVID protocols and social distancing is followed. Big companies like Walmart and Swiggy are looking to use aerial vehicles and drones for delivery purposes. Apart from this, they are also used in lunar space excavations. With the applications of drones ever increasing by the day, the need for autonomy is prevalent. Now Archana will continue with this purpose. Thank you.
So the main purpose behind this project and the reason for choosing a deep learning approach is due to the robustness of this approach and the ability to adapt to different use cases and scenarios. Moreover, the approach which will serve as a backup in case of sensor failures and GPS denied environments. So traditionally, drones use GPS for location estimation and safe landing. But in most cases, the drones have to navigate through environments where GPS is denied, and apart from this, GPS is also subjected to errors in position measurements, hence they are extremely unreliable. Therefore, we go for a deep learning approach. So that was our main purpose. This is the system design. In the system design, we initially have a drone, which is a quadcopter provided by Airsim. Provided by Unreal Engine, which is a game engine developed by Epic Games. This drone is then navigated and controlled using certain APIs which are provided by Airsim. Airsim is a simulator for drones and cars built on Unreal Engine. The record feature of Airsim is used to record training data, and then these frames are further passed on to the neural network. And then the neural network is then responsible for processing and training the data to give velocity as the output, which is then passed to the guidance controller. So that is our overall system design. Data is the most important factor when it comes to deep learning models. So the major challenge of our project was to find data, as data sets are not readily available. Moreover, the problem was that even when we found readily a certain data sets, we could not find a data set where a certain image frame was corresponding to a ground truth. And these were the general challenges regarding data sets that were faced by our project. So, yes. Thank you.
Hello, now that we have established that we need a data set which has images and its corresponding ground truth, which is the velocity. The dataset generation is done using Airsim Simulator. It is an open source simulator from various objects like drones, cars, and it is built on Epic Games Unreal Engine 4. It has proved to be a boon for various research work to get the image dataset. So here is the image, which is a still from drone simulation. Here are the three views. The first is the depth view, the middle one is the segmentation view, and the third is the first person view from the drone. So Unreal Engine is a development tools which gives you flexibility and independence to add various virtual worlds ranging from buildings, schools to mountains, beaches, oceans, and even exoplanets, moon, Mars, etc. This is the landscape mountains environment which we used for our project to generate the data set. As we can see in the following three images, we can see real life mountains, trees and river as well. These are the few image frames example from our generated dataset. The leftmost is the image taken from the drone which is high above the ground. The middle one which is approaching the ground, and the last one the drone is just about to the land. Since it is a landing task, the camera is facing downwards and we can see the ground view. So this is the golden treasure, I would say, of our project, which is the data set, which we can see that for each image frame we have all these values which are important to ensure the soft landing. The values range from position xyz, its orientation xyz, latitude, angular acceleration, linear velocity as well as angular velocity. The one which our project will be focusing on will be the linear velocity for the drone. Thank you.
Now, from this huge data set that we need only the image path of the image frames, the timestamp for the image frame, and the velocity of the drone at that particular frame. So these are the three attributes that we choose from our data set. We have used around 15,000 image frames for training the model. After experimenting with various models, we decided to go ahead with the NVIDIA model. This model makes use of optical flow and a convolutional neural network, which helps in obtaining the spatial features from consecutive image frames. LSTM layers are used to extract the temporal features between the frames. These spatiotemporal features are used to estimate the movement of pixel between two frames, which is used to calculate the velocity of the drone. This is the output of the model we trained. We used around 15,000 images for the training. As you can see, the error keeps reducing with increasing epochs. This is a small snippet of the drone landing and the velocity of the drone as it lands. Here we can see the actual velocity, the predicted velocity, and the error. For implementation of this model, the hardware needed is a Jetson TX1 module, which is a supercomputer, which will be used to process the images and estimate the velocity. Then a 3DR Iris quadcopter. Along with this, a J120 carrier board is required to connect the Jetson supercomputer module. So velocity estimation is one of the many attributes required to ensure a soft landing. Our project is going to be used by our guide who has a sponsorship from ISRO. Considering the various applications of drones as discussed earlier, the entire system will also be useful in maneuvering of drones in agriculture, delivery systems, etc. These are the references that we used. Thank you.
Hello, now we'll be looking at the demo of how we generated the dataset using Airsim Simulator. So this you can see is the Unreal Engine 4 Airsim Simulator software. So in order to place drone in the environment, I will hit play. Now the drone has been placed in the landscape mountain environments. In order to move this drone, we have to run a Python script. So I'll explain the Python script later. First we'll run the script, which is hello drone.py. So now I have ran the script and now the drone has took off. So this is the full screen view, and now if you want to see what the drone says, we'll switch to the camera view. As we are focusing on the landing task, the drone camera is facing downwards, and we can see now the drone is taking off. We have started the recording of our data set once the drone has started landing. As we can see, the drone has now started its landing. It is moving very slowly and we can see the difference if we focus. So by the time the drone lands, I'll explain the Python script. So we have used takeoff function for the drone to take off. After that, we took the drone to the required position and then we start the landing. But before starting the landing, we also start the recording since we need the data set. And once the drone has landed, we have all the data set which we need for our project. So now to see how the drone looks in the environment, so this is how the drone is landing. Now we can clearly see that drone is moving down. And again, to switch to the camera view, I'll press F. Now the drone is almost approaching the ground. As we can see, it has real closer to the ground and it is about to land. And that's our final aim, which is to perform a soft landing. From the altitude which we started, we can see that drone is just about to touch the ground. See, the drone is just about to touch the ground. Let's switch to the camera view. Now the drone will. As we can see, the drone is now completely landed, and thus we have generated a data set. Thank you.